OSPF router LSA or LSA type 1. In this video, I am going to talk about the OSPF link state advertisement LSA type 1. You know that in OSPF, we are using the link state advertisement or link states for propagating the link states information between the routers. You know that, for example, R1 should create its link state and should send its link state to the router 2 and the router 3. Also, the router 2 should create its link state and should send it to the router 1 and router 3. And finally, the router 3 also should create its link state and send this link state to the router 1 and router 3. Finally, each router, in its local database, we call it LSDB or link state database, it should have LSA of the router 1, LSA of the router 2, and LSAs from the router 3. And after that, after creating this LSDB, actually the router 1 has the topology of this network. Actually we have a synchronized LSDB between the routers in one area. After that, after this LSDB creation, actually the topology of the area, we can run the SPF algorithm or shortest path first algorithm on this LSDB, and finally we will have the best path to reaching to other destination networks in this area, and we can use the result of the SPF into the routing table. We can inject the result of SPF to the routing table. You have learned about this feature in previous videos. Now I am going to talk about the detail of the link states because it is so important for us for other features, for other optimization related to the OSPF. First, we should understand the content and the different behaviors of the LSAs in the OSPF. After that, we can understand, we can learn about more features, more configurations, and more, for example, tools related to the OSPF. Let me to say that in OSPF, we have different types of LSAs. As you can see in this table, we have 11 types of LSAs: LSA type 1, LSA type 2, LSA type 3, type 4, 5, 6, 7, 8, 9 to 11. And we are using these LSA types for creating the topology of one network. Maybe in one network, in one area, we have only one type of these LSAs, or maybe two type of this LSA, or maybe more or less. But actually we can say you can use these different types of the LSAs for creating the topology of one routing network. I will talk about them. Don't worry about the, for example, numbers of the LSA. For example, we have 11 type of LSA. This is so hard to understanding all of them. No, it is easy. You should step by step learn about these LSAs. Finally, you can use them. It's not so hard. But this is important to learn the detail of the LSAs. Step by step. I'm going to talk about the simplest form of the topology that we have in the OSPF. The simplest form of topology in the OSPF is a single area network, is a single area routing domain with only the point-to-point networks. You know that here we have 3 point-to-point networks between the router 1 and router 2, router 1 and router 3, and router 2 and router 3. Also, we have here 3 LANs, and here we don't have any DR and BDR. The simplest form of the OSPF network is a single area network without DR and BDR networks. That's it. In this video, we will learn about this type of networks and how we can draw this type of networks with OSPF. In the next step, at the next video, you will learn one step more. One area, single area, but with DR and BDR routers and networks. In the video after that, we will learn the next, for example, complex scenario in multi-area scenario. You will learn step by step about all of these LSA. In this video, we will learn about only the LSA type 1, this LSA. We call it the router LSA. Let me to say that each LSA has a type and has a name. You can say LSA type 1 or you can say router LSA. Both of them are same, okay? Or you can say LSA type 2 or network LSA, LSA type 3 or summary LSA or network summary LSA, okay? You will learn about them, don't worry. Let me to start with this simple scenario. As you can see here, we have only one area, and this is the backbone area, and also we have only point-to-point networks, okay? And also some LANs. That's it. As you can see here, we have the addressing of these networks, the subnetting. First, I will explain what we expect to happen. After that, we can implement this scenario and verify our result with the show commands. Okay, let me start talking about this scenario. The first thing that you should know is that in the OSPF networks, okay, each router should create only one LSA type 1, okay? Because of that, we will have one LSA type 1 with the router 1. LSA type 1 or router LSA, both of them are same. LSA type 1 of the router 1. Also, we have one LSA type 1 from the router 2 and one LSA type 1 from the router 3. Then they should, okay, advertise these LSA type 1s to each other. For example, finally, the router 2 should have the LSA type 1 of router 1 and the router 3 should have LSA type 1 of router 3. Then router 1 should have LSA type 1 of router 2 and router 3, and the router 3 should have LSA type 1 of the router 1 and router 2. Let me to emphasize that it is not, for example, equal for all LSA types that about everything. For example, LSA type 1 is creating by all routers, but LSA type 2 should not create by all routers. You will learn about it. For example, LSA type 2 only is creating by the DR or designated router. Because of that, about the LSAs and some of the detail related to them, we have some differences. Let me to talk about the content of the LSA type 1. It is so easy. Before talking about the content of LSA type 1, let me to remember that in the OSPF, about the cost of interface, for fast Ethernet, we have the cost of 1. We have calculated this before. And about the serial interface, we have the cost of 64. Here, we have some fast Ethernet. This is fast Ethernet. And this is the serial. Okay, because of that, the cost of this interface is 1. The cost of this interface is 64. That's it. Let me to show you what is the concept of the LSA type 1 of the router 1. I'm going to write here router 1, okay, LSA type 1. This is the router 1, LSA type 1. It is so easy. Look at here. In the LSA type 1 of router 1, we have the router ID of this router. Assume that the router ID of router 1 is quad 1. Then here we have some information. First, router 1 should say that I have connected, okay, to, for example, these networks, for example, to the network 10.1.20/24, okay, and also with the cost of the 64. Cost of the interface I am connecting to this network is the 64. Then I am connecting to the 10.1.30/24, okay, with the cost of again 64. That's it. Then I connected to the 10.1.00/24 with the cost of 1. This is the first information. The next information, with the IP address, with the interface, okay, IP of the 10.1.21, I am connected to the router ID quad 2. Look at here. Let me to review it. You know that R1 has neighborship with router 2. Also, R1 has neighborship with router 3. This means that R1 knows about the router 2 on this interface and about the router 3 on this interface. R1 knows that with the 10.1.21, the IP address of this interface, okay, it is connected to the router 2. And also, with the interface IP of the 10.1.31, R1 connected to the router ID quad 3. That's it. Okay, here you can see all of the information of the LSA type 1 of the router 1. It is so easy. But let me to add something to this information. Look at here. In the LSA type 1, maybe you see some terms. For example, maybe you see the term stub. What does the meaning of the stub? It is not related to the EIGRP stub. A stub means on that interface, okay, we have only one neighbor, and that is the, for example, point-to-point network. Actually, this is a stub network, and also this is another stub network. Okay, a stub network means we have one neighbor over a point-to-point interface, or we have, for example, connected to one LAN without any neighbor. Actually, in these two type of networks, you see the term of stub. R1 with the serial interface means without DR and BDR connected to R2. This is a stub, and also R1 connected to the, for example, one LAN. Okay, assume that this is our LAN, and again this is a stub. Because of that, you will see these terms here. I am connected to one stub network. Okay, this is the stub network. You will see it. And then this stub network's IP address is 10.120/24. Again, another stub network. For example, I am connected to the 10.130/24. This is a stub network. Also, this is a stub network. That's it. You will see. Don't worry. Also, maybe you see the term point-to-point means I am connected with one point-to-point link to router 2 and to the router 3. The detail is not important. You will see them. Okay. Let me to talk about the router 2's LSA type 1. I'm sure that you can expect the LSA type 1 of router 2. For example, in the router 2 LSA type 1, we have this information. My RID is quad 2. That's it. Okay, I am connected to the 10.120/24 with the cost of 64, and this is a stub network. Then I am connected to the 10.20/24 with the cost of 64. This is a stub. And also I connected to the 10.200/24 with the cost of 1. This is a stub. With an interface IP of 10.122, I connected to the router ID of quad 1. And with the 10.232, I am connecting to the router 3 or RID of quad 3. That's it. And then let me to show you the LSA type 1 of the router 3. RID in this LSA is the quad 3. Okay, and here you can see that we have connectivity to the 10.130/24 with the cost of 64. This is a stub network. I connected to the 10.230/24 with the cost of 64. This is a stub. I connected to the 10.300/24 with the cost of 1. This is a stub. With interface IP of the 10.133, I connected to the router ID quad 1. Here also we have the cost, but the cost is not so important. Then here with the IP address of the interface IP of 10.233, we have connected to the RID of the quad 2. That's it. Okay, this is the here we can see the information that we have in each of these LSAs. Also, you know that R1 should send this its link state to the router 2, and then to the router 3, and also router 2 to router 1, to router 3, and router 3 to router 1 and router 2. You have learned about the process. Assume that now we have this information in all routers. For example, in the router 1, we have the LSA type 1 of router 1, router 2, and also router 3. And now in the router 2, we have LSA type 1 of router 1, router 2, router 3. And finally, in the router 3, we have LSA type 1 of the router 1, router 2, and router 3. I am going to show you that with this information, okay, now we can draw the topology. Assume that we are residing in the router 1 and we are trying to create this topology with these LSAs, because you know that in the LSDB of router 1 now we have this information. Okay, as you can see now, R1, assume that we are residing in the R1. R1 has three LSAs, three LSA type 1 received from the itself, and also router 2 and also router 3. Let me to show you what is happening. Look at here. Assume that this is the router 1. Because we are receiving three LSA type 1, this means that in this network we have three routers. This is the router 1. We can draw the topology easily here. I'm going to show you how these routers are using the LSA type 1 for creating the topology in their mind. Okay, here we have three routers: router 1, router 3, and router 2. Okay, and we can start the drawing of network from one of these routers. You know that we are residing in the router 1, and the identity of router 1 is its router ID. Actually, we don't have our ID. We don't use the R1 as it's our host name for our identity. Our identity in the topology is our router ID. Okay, quad 1. Also, because we are receiving two LSA type 1 with the quad 2 and quad 3, we know that in this topology we have two other routers. Okay, quad 2 and then quad 3. This is the start point of our drawing. Okay, assume that R1 receiving this information. I'm going to talk about the LSA type 1 received from the router 2. As you can see, in router 2 we have this information. I have connected to the 10120/24 with cost 64, and also I have with 10122 I have connected to the for example router with the router ID of quad 1. What does it mean? The R1 with these two line, or quad 1 with these two line, can understand here we have one pass, okay, one link between the router 1 and router 2. Let me to say that between the quad 1 and also a quad 2, okay, because as you can see here we have this information. With the 10122 I am connected to the router 1, okay, RID quad 1, and also the range of this address 10 is 10120. The range of this link is 10120/24. Why? Because 10122 is one of the IP addresses residing in this network. Actually, we have this information, this interface, or let me to say that the range of this link is 10120/24. Now we know it. Okay, and after that we know that here in the side of router 1 this is the point 1, the point 2, 10122. Okay, and also as you can see the cost of this interface is 64. It is so easy. We can understand these three information from the for example this two line 10120/24 cost 64, and also with the 10122 I am connected to the router 1. That's it. Okay, and then from the LSA received from the router 2 we can understand that we have in the router 2, in the quad 2, we have 10230/24. The router 2 connected to 10230/24 with the cost of 64, and also with the 10232 connected to the router 3. Actually, now we have this information. Let me to show you. Router 1, okay, connected to the router 3, as you can see. Router 1 connected to the router 2 connected to the router 3. Why? Because it says that I am connected to the router 3. Look at here. We have one link between the router 2 and router 3. You know that from the router 1 we are drawing this topology, and we know that the IP address of this link, the range of this link is 10230/24. Why? Because here in the LSA type 1 content we can see 10230/24/24. Okay, 10230/24 is the range of this network, and also the cost of this link is 64, and the IP address of the router 2 is 0.2 10232. That's it. And then also in the router 2 we have another line. I have connected to 10200/24 with the cost of 1 without any more information. This means that the router 2 has also one connectivity to this network without any neighbor. This is like a LAN. Okay, we know that in LAN we don't have any router. Because of that, now we know that the range of this network is 10. For example 200/24, and also the cost of this interface is 1. Here you can see the cost of this interface. Okay, now from the router 1 we have this information. Let me to talk about the LSA received from the router 3. From the router 3 we have this information. I have connected to the 10130/24 with the cost of 64, and also with the 10133 I have connected to the router 1. Actually, we can understand easily that from the router 1 we have a link to the router 3. Why? Because the router 3 sends this information to us that I have connectivity with the 10133 to the router 1. Actually, here we have the IP address of the 10133, and we know that the range of this link is 10130/24. Here you can see 10130/24, and also the cost of R3 to this subnet is 64. Let me to show you. Here we have the cost of 64, and this is the 0.3, 1013.3. Look at here, 1013.3. We have connectivity to the router 1. That's it. Then here you can see that I have connectivity to the 10230/24 with the cost of 64. Actually, here we can understand that this link has cost of 64. And then with the IP address of the 10233, I have connectivity to the router 2. It is so easy to understand that this is 0.3, 10233. Okay, and here now you can see all of this information. Also, we have another line. I have connected to the 10300/24 with the cost of 1 without any other neighbor. Because of that, we can understand that this is a LAN 10300/24 with the cost of 1. Actually, now we know that the router 3's information can give us this topology. Then the LSA received from the router 1, the RCEF LSA 10120/24 reachable with the cost of 64. Here we have the cost of 64. It is so easy. Okay, after that 10130/24 cost is 64. Again, here we are using the cost of 64. Then as you can see, 10100/24 cost is 1. It is so easy to understand that here we have one, for example, LAN, and the IP address of this LAN is 10100/24. Okay, and the cost of this interface is 1. That's it. Then with the 10121, I have connected to the router 2, to the quad 2. Because of that, we can understand that here we have the IP address of the 0.1, 10121. And in the last line, we have this information. With the 10131, I have connected to the quad 3. This means that again, here is the, for example, a 10131. That's it. As you can see, each router can create the topology. In this topology, we don't have any effect related to, for example, the name of the interface, serial, fast Ethernet. It is not important. We don't have any need, okay, to know about the type of interface or some other things. We need only the topology. This is the topology, the IP addressing, and also the cost. That's it. Okay, this is not important that this is serial interface or fast interface. Only it is important for us to knowing about the topology, and after that about the IP address and also the cost. Now, as you can see, with the LSA type 1, we can easily draw the topology of one network in a single area, a network in a single area topology, and only when we have the point-to-point networks. Okay, let me to implement this scenario, and after that we should see these LSAs inside the LSDB. And let me to say that if you want to verify the LSDB, you can use the show IP OSPF database. But if you want to see only one type of LSAs, okay, you should use this command, show IP OSPF database. Okay, then the LSA name, you know that the LSA name is router LSA. For example, about the LSA type 1, you can use this command, show IP OSPF database, then a router. What does it mean? It means that I want to see all of the router LSA, means LSA type 1 inside the database. But you know that with this command, we will see all of these 3 LSAs. Maybe you want to see only one of them. Each LSA has one LSA ID. Look at here. Each LSA has one LSA ID. About the LSA type 1, LSA ID is the router ID of the advertiser router. For example, LSA ID of this LSA is quad 1. The LSA ID of this LSA is quad 2 because the router 2 advertise these LSAs and also or generate this LSA. And then in the router 3, the LSA ID of this LSA is quad 3. If you want to see only one of the, for example, LSAs from one specific type type of LSA, you can use show IP OSPF database. First, the LSA name, second, the LSA ID. For example, for verifying the LSA type 1 received from the router 1, you can use show IP OSPF database. Okay, then router means please show me a router LSA received from the router 1. LSA ID is quad 1. It is so easy. Look at here. With show IP OSPF database, you can verify all of the link state database. Okay, with show IP OSPF database LSA name, you can verify only the one specific LSA types. For example, LSA type 1, LSA type 2, LSA type 3. But when you want to verify to see the content of one specific LSA, you can use show IP OSPF database, first LSA name and then LSA ID. Show IP OSPF database router means from LSA type 1, I want to see exactly the LSA type 1 of router 1. In the router LSA or in the LSA type 1, okay, the LSA ID is the router ID of the advertiser router. Now, let me to implement this scenario and verifying all of the contents I have explained until now. Let me to implement this scenario. It is so easy. Look at here. We have router 1, router 2, and router 3. Let me to show you the labels of each interface. Okay, first we should configure this scenario. Starting from the router 1, conft interface serial 10. IP address of this interface is 10.121.255.255.255.0. Then no shutdown, then interface serial 11. Okay, IP address of this interface is 10.122 or 10.1, okay, 31 255.255.255.0. and then no shutdown. Also we have interface fast ethernet 00. IP address of this interface is 10.101, for example 255.255.255.0. let me to configure the OSPF on this router OSPF 1. I'm going to configure the router ID is quad 1, then network 10.101 quad 0, okay, for in the area quad 0 again, and after that network 10.121 quad 0, and then area quad 0, and after that network 10.131 quad 0, area quad 0. Before configuring the other routers, let me to show you the database of router 1. Show IP OSPF database. This is the database of router 1. As you can see, we have this information, only one LSA type 1. Why? Because we didn't configure the router 2 and router 3. Here we have the LSA type 1 of router 1. OSPF router ID is quad 1, process ID is 1, router OSPF 1, and this is the router link state. Router link state means LSA type 1 for area quad 0. And then link ID means LSA ID. You know that the LSA ID is equal to the advertiser router ID. Advertiser router ID is quad 1 and LSA ID is quad 1, as you can see here. The age of this LSA is 20 seconds. You know that after creating one LSA, we will have one age. Again, look at here. The age now is 62 seconds. You will learn more than this about the age, but for now, let me to say that when we are creating one LSA in one router, the age should be incremented from 1 second to 2 seconds each second. Okay, it should increment by one number. Okay, this is a sequence number. You know that the sequence number is a 32-bit identifier, and actually this is a version of this LSA. When we are experiencing one change, we are incrementing the sequence number and offering this sequence number or this LSA to other routers. Other routers with this sequence number can identify that this can understand that this LSA is newer than the other routers LSA, and for example they can send requests to receiving this LSA. Here also we have the checksum for noise free detection of the LSA, and also here we have another option, link count. I will talk about that. For now, let me to configure the router 2 also. In the router 2 now we don't have any information about the OSPF. The conf interface serial 10. IP address is 10.122.255.255.255.0. No shutdown. Interface serial 11. IP address is 10.132.255.255.255.0. then no shutdown, and then interface fast Ethernet 00. IP address is 10.202.255.255.255.0, then no shutdown. Then let me to enable the OSPF, router OSPF 1, router ID is quad 2, network, okay, let me to use the network command, network 10.202 quad 0, again area quad 0, after that network 10.122 quad 0, area quad 0, we will have neighborship between with the router 1, and then 10.2 network 10.232 quad 0, then area quad 0. And finally, let me to configure the router 3. But before configuring the router 3, now in the database of router 1, you can see we have two LSA type 1. The first from the router 1, the second from the router 2. In the router 2 also, do show IP OSPF database. We can see that we have two LSA type 1. Let me to configure the router 3. This is the router 3. Okay, and here we can start the configuration with the conf t interface fast Ethernet 00. IP address of this interface is 10.3.255.255.255.0. Then no shutdown. After that, interface serial 10. IP address of this interface, okay, the serial 10 is 10.1, okay, 3.3.255.255.255.0. Then no shutdown. And finally serial 11, okay, the serial 11 IP address is the 10.233.255.255.255.0. Then no shutdown. Then let me to enable the OSPF, router OSPF 1, router ID is quad 3, okay, then the first network statement 10.3.0.3 quad 0, area quad 0. After that, network 10.133 quad 0, area quad 0. We will have neighborship between the router 1 and router 3. And then network 10.233 quad 0, area quad 0. Now we will have neighborship between the router 2 and router 3. This is the configuration of router 3. Now let me to show you the database of router 1. Show IP OSPF database. Okay, you know that in the database of router 1, okay, we have 5 line, okay, or we have 5 link information. Because of that, here you can see the link count is 5. Also in the LSA of router 2, we have 5 line information, the link count is 5. And finally in the router 3 also we have 5 link count. Because of that, now we can easily understand all of these contents. Okay, now let me to show you the detail of LSA received from the router 1. Look at here. Let me to compare the LSTB of these 3 routers with each other. I'm going to show you that we don't have any difference between the LSTB of router 1, router 2 and router 3. Okay, let me to show you IP OSPF database in router 1, in router 2 show IP OSPF database, and also in the router 3 show IP OSPF database. Let me to review them. Look at here, R1, R2, R3. We don't have any difference, only the age is different, and this is not important because age is incrementing value. Look at here, as you can see, everything is same. Because of that, it is not important to verifying the LSA type 1 of router 1, router 2 from which router. In all routers, we have the same information. For example, we can start from the router 1. Show IP OSPF database, then router means please show me the detail of all LSA type 1s, but I'm not going to see all of the LSA type 1s details. Only I want to see the LSA type 1 received from the quad 1. Here you can see we are using this link ID. What are the information in the LSA type 1 of the router 1? We expect that this information should equal to this information. Okay, let me to show you. Here you can see the LSA type 1 received from the router 1. Okay, starting from here. Here we can see the header of the LSA type 1 received from the router 1. OSPF router ID is quad 1, it's okay. And then process ID is 1. As you know, there here we have the RID of quad 1. Router link state for area 0. Yes, we are working in the area 0. This is the LSA age. It is okay. We don't know about the options. We will learn about the option in future features, but not now. LS type means link state type is router link state. Yes, it is router link state or LSA type 1. Link state ID means LSA ID. LSA ID is quad 1. You know it that in the router LSA, the LSA ID is equal to the advertiser router ID. Then advertising router also is quad 1. It is okay. LSA sequence number is this value. Okay. Checksum this value. Okay. Length of this LSA is 84 byte. It is okay. Number of links is 5. 1, 2, 3, 4, 5. Now, here we can see the content of this LSA. Link connected to another router point to point. Okay, now as you can see, we have the point to point connectivity to which router? From the 10131 to the quad 3. From the 10131 to the quad 3 with the cost of 64. Look at here. With 10131, we have connected to the quad 3. This here we can see this information. Okay. Let me to show you with another color. Okay, here we have this information. It is okay. And also here we have the cost. Yes, you can write the cost here. I have explained it, but because here we have cost, it is not important. Okay, and then as you can see here, we have the next line. I have connected to 10130/24. Okay, with the cost of 64. 10130/24 with the cost of 64. And you know that this is the information that we have in this line. Okay, then I have connected with the 10121 to the router 2 quad 2. Okay, here you can see this information. Then here, as you can see, I have connected to a stub network. Look at here, both of them are a stub network, as you saw. Then I have connected to 10120/24 with the cost of 64. This is a stub. It's okay. Okay, and after that, at the last line, I have connected to 10100/24 with the cost of 1. This is the stub network. It's okay. As you saw, now we have all of these informations on the RID, on the LSA type 1 received from the router 1. Now, let me to show you the information in the LSA type 1 received from the router 2. Show IP OSPF database router quad 2. Again, here we have initial information. This is the LSA header, but here we have the detail of the LSA. As you can see at the first line, you can see that I have connected with the 10232 to the quad 3. Okay, this is the LSA of the router 2, 10232 to the quad 3. It's okay. After that, I have connected to the 10230/24 stub network with the cost of 64. It's okay. And here you can see this information. Then I have connected with the 10122 to the quad 1. It's okay. You can see it here. And after that, here you can see I have connected to 10120/24 with the cost of 64. Again, it's okay. And finally, I have connected to 10200/24 with the cost of 1. That's it. Okay, then let me to show you the information that we have in the LSA received from the router 3. Show IP OSPF database router quad 3. That's it. Look at here. Again, I have connected with the 10233 to the quad 2. Okay, you can see this information here, 10233 to the quad 2. Then I have connected to the network 10230/24 with the cost of 64, and this is a stub network. Because of that, we have this information. Okay, 10230/24 with the cost of 64. Then I have connected with 10133 to the quad 1. Let me to show you 10133 to the quad 1. That's it. And then I have connected to the 10130/24 with the cost of 64. Here you can see this information. And finally, I have connected to the 10300/24 with the cost of 1. As you can see, now we know about the detail of the LSA type 1. Let me write here. In the LSA type 1, we have this information. First, we have connected to the stub network. Okay, and in this the network address of this stub network, and also the mask of this stub network, and also the cost of this stub networks. This is the first entry. Then we have this information. We have interface IP and the neighbor router ID, and also we have cost. But let me to say that in the next video, in the LSA type 2, you will see that in LSA type 1, in some cases, we have another information. But here, in the LSA type 1, we have experienced this type of information. Look at here, a stub network, then mask, then cost. And then interface IP, and after that, neighbor router ID, and also the cost. Also, you know that in the LSA type 1, we have the router ID of the advertiser router. Let me to write here, router ID. because you know that first the router 1 should send its router ID. After that, it should send the information related to the stub network and mask and cost, and also interface IP, neighbor RID and cost. Now you have learned about the LSA type 1, okay, and also its content. Let me to say that in all of the LSAs, not only LSA type 1, we have age. Let me to show you again, show IP OSPF database. Okay, we have age and sequence number. You know that every time we are receiving one newer version of the LSA, okay, this age should be reset to 0, and again we are starting. You have learned about it in the previous video. Okay, let me to show you again. For example, in the router 3, let me to shut down the interface fast Ethernet 00. Okay, now we are receiving one new LSA from the router 3. Look at here, the sequence number incremented by one value, and the age resetted to 0. That's it. Okay, let me to enable it again, no shutdown. After some second, you can see that here we will have one new LSA. Look at here with the sequence number of 5 and age is 0. You know that for each LSA type 1, okay, we should calculate new SPF, or we should run again the SPF. Also, let me to say that in the OSPF, okay, we are sending the updates when we are experiencing a change. For example, this means that in OSPF we are using incremental update, but in OSPF, we have another mechanism. Okay, this is for helping to synchronizing the database of the all routers. In each 1800 second, means in each 3 minutes, okay, each router should create again its link state, and it should send to other routers. Assume that here now R1, okay, sent its LSA type 1 to the router 2 and router 3. You know that this is the LSA type 1 of the router 1, okay, and as you saw, we sent this LSA type 1, okay, to the router 3 and to the router 2, okay, and after 30 minutes without any change, for example, we don't have any change in related to the links that we have in this LSA type 1, but because that the 30 minutes is passing from the for example, is passed from the previous LSA advertisement, in the next interval of 30 minutes, we should send new LSA type, but with one sequence number higher than before. For example, in the previous time we have sent the LSA type with the sequence number of, for example, 0x8601, okay, and now all routers have this information, LSA type 1 of router 1 with this sequence number, okay, but without any change, we are sending after 30 minutes the next LSA type 1 with incrementing one value in the sequence number. Why? Because we want to other routers accept this LSA type 1. Why we should refresh the LSAs? This is the refresh time in the OSPF, because we want to ensure that all routers, okay, have the latest version of the LSA. Because of that, we expect to see in all routers in each 30 minutes the age should be reset to 0. Okay, in most cases we can see it, and when the age is incremented to 1800 seconds, we are receiving one LSA, and the LSA age should be incremented. Maybe in some implementation you see a little different value, for example 35 minutes, 34 minutes. It is not important, but finally after 30 minutes or a little more, a little less, we should see that the age is reset to the 0 without any change. This can help the OSPF about the synchronizing of the database. Also, let me to say that in OSPF, if age of one record, okay, reach to 3600 seconds, why one record's age should reach to this value? Because that record doesn't update, okay, for 2 periods. In one period, 1800 seconds, we didn't receive the update. Again, after 1800 seconds, we don't receive the, for example, refresh LSA. This means that we have a problem. That LSA should be purged, should be deleted from the routing table. This means that in the routing table, if one LSA age reaches to 3600 seconds or a little more, for example, 3600 seconds, 9 or 10, that LSA should be deleted automatically from the routing table. Actually, in most cases, we can see the LSA age with lower number of 1800 seconds. When we have a problem, maybe you see the LSA age near to the 3600 seconds, okay? And after that, after some seconds, you can see that LSA should be removed from the routing, from the link state database. You will learn more than this about these features in future, but for now, let me to review. In OSPF, we have different types of LSAs. LSA type 1 to LSA type 11, okay? Each LSA is useful for one type or maybe in some type of the networks. In network with only single area and with the stub links, means the point-to-point links and also the Ethernet links without any neighbor, we need only LSA type 1 for drawing that network. In the next video, I am going to show you why we need the next type of LSA, for example, LSA type 2. Okay, but in this video, we have learned about the detail of LSA type 1, the content of LSA type 1. Also, we can create one topology with the LSA type 1 ourselves, and this is so important. Now it's your time. You need to create one network, okay? Before configuring that network, you should expect for example, predict the LSA type 1s of that network, okay? And after that, you can configure that network in the, for example, GNS3 or, for example, the EVE-NG, and then verify the database. If the database is equal with your for example, prediction, this means that you can you understand completely the LSA type 1. After that, you can learn the LSA type 2. It is so important to learning LSAs in a step-by-step, for example, manner. If you don't learn LSA type 1 completely, you cannot learn LSA type 2. Okay, after learning the LSA type 1, after reviewing the topics in this video and also practicing this video, please come with me to the next video. In the next video, we will talk about the OSPF LSA type 2. We call it Network LSA.